In example 3, I want you to determine the implied domain of the following functions. So we see both neon lights here. In A, we have a radical, meaning we want to make sure the radicand will not be less than 0. And in B, we have a denominator. So we want to make sure the denominator will never be 0. Let's address the function in part A first, f of x. We focus on that radical sign. So we want to make sure everything that's underneath that radical must be greater than or equal to 0. We solve for x. We get negative x is greater than or equal to negative 3. X is less than or equal to 3. The rest of our function is a 5x minus whatever it's under the radical, and that doesn't put any restrictions on our domain. So all we really need to worry about is that radical. And this tells me that the domain for this function must be x less than or equal to 3, or in interval notation, negative infinity to 3 inclusive. Let's move on to the next one, which is when we have a variable in our denominator. So in g of x, we should pick out that denominator and realize that we cannot have a denominator equal to 0. We want to figure out then what values of x will cause x squared minus 1 to be 0. So we can factor out, because this is the difference of squares, and realize that if x was a negative 1, this factor would go to 0, and 0 times anything in this factor will make the whole equation 0, so that would be a problem. Also, if x was a positive 1, this factor would be 0, and no matter what this factor is, we would have this factor times 0, which is still 0, and that would be a problem. So we find that x cannot equal plus or minus 1. In interval notation, we say that x can be anything from negative infinity to negative 1, exclusive, because we can't be a negative 1, or we can be anything from negative 1 to positive 1, or anything from positive 1 to positive infinity. And this is our implied domain. Hopefully this made sense. So just a quick review. We know that functions mean that for every input there is one and only one output. We can test that in graph, where we use the vertical line test, table, where we look for repeat inputs with different outputs, or equation form, where we look for a y raised to an exponent or a plus or minus sign. And then finally, we talked about mapping, in particular domain, codomain, and range, and how to pull out the domain, codomain, and range from problems. And as a subtopic, we talked about the implied domain and the importance of looking for those even roots and the denominators. Review these notes if you need to. If not, you're more than welcome to go on to the next section, which discusses linear and quadratic functions.